Hello children. In last video we had studied about vibration, oscillation, oscillatory motion, vibratory motion. After that mean position during oscillatory motion or vibratory motion, and then amplitude, time period and frequency. Okay. Now let's start another topic of this chapter that is related to vibration and oscillation also. So the another topic is wave. That is wave and wave motion. Although it is not given, this term is not given in our NCERT book, but we should know this one, wave and wave motion. Whenever any disturbance is created in a medium, that disturbance is called wave. What? Whenever any disturbance is created in a medium, that disturbance is called wave. So like suppose if we have a calm surface of water and we touch the calm surface of water, but we will find ripples will be produced around that point. So that is, we created disturbance, we added energy in that medium, in the surface of water, and due to that disturbance starts traveling from one place to another place on the surface of water. So whenever any disturbance is there in any medium, that is called a wave. Like suppose children, this one is slinky. So if we have this slinky, its original shape is this one, and if we stretch it and then create a disturbance over here, only we create disturbance here, we disturb the turnings of this slinky at this one end. Then what will happen, that we will see that all the turnings of the slinky gets disturbed, means that disturbance starts propagating, traveling from this end to this end of the slinky. And what is slinky? Slinky is a coil-like thing made of soft metal. Soft metal, not we can say, it is made such that its shape can be changed, and then the different kind of wave can be shown on this one. So like so what we studied, that wave is a disturbance created in a medium. After that wave is a disturbance created in a medium. Whether the medium is solid, liquid or gas. So that is called wave. Now propagation of wave means disturbance propagates, travels from one place to another place in the medium, and that is called wave motion. So propagation of wave is called wave motion. Propagation of wave is wave motion. Propagation of wave through a medium, we will say through a medium is wave motion. Okay. Now how many kinds of wave motion are there, that we will study. Suppose if you understand only one type of wave, then next type we will study on next day. Now wave motion or wave motion will be like this. One is longitudinal wave, and next one is transverse. transverse wave. Wave motion, longitudinal wave and transverse wave. Now we will study each one of them one by one. Now longitudinal means towards the across the length. So what happens in this wave that when the disturbance is created, like we have this slinky and we create disturbance at one end of the slinky. Over here I pull and then leave. Then what happens that the turnings of the slinky will start executing back and forth motion, and by this way the disturbance will reach till the last end of the slinky. So what is happening that the disturbance is created here, but that disturbance travels along the length of slinky. Okay, disturbance, direction of propagation of disturbance and the vibration of the turnings of slinky are in the same direction. So here what happens that the disturbance propagates along the lengthwise of the slinky. So this kind of wave is known as longitudinal wave. Like suppose if we keep some books like this on the table, two book like this, again two book like that. If we keep the books on the table and then we struck one end of the book, what we find that all the books will fall down along the same direction in which we have applied force. So over there the disturbance propagates along the length of the arrangement of books. So that kind of disturbance created in a medium and propagated in a medium is called longitudinal wave. Okay. Now another example for that one is sound. When we speak something, sound is produced. When we speak something, what happens? This sound energy gets added in the medium. Disturbance gets added in the air and then the air molecules start vibrating. But in which direction? Sound will travel all around and the molecules along the direction of motion of sound will start executing back and forth motion. Sometimes the sound energy will push air molecules ahead, then the sound will be transferred to the next molecule. Again the molecules which had been got compressed come closer to each other due to the sound energy will come back, transferring sound energy to the next molecule. So what happens during propagation of sound? At some place the air molecules get compressed, come closer, and on the other at the other point air molecules after transferring sound to the next molecule again come back, creating what? A rarefaction. Compression, rarefaction, again I am showing you by slinky. So this is rarefaction in the slinky. When we create disturbance in the slinky, what happens? What we see that slinky somewhere come closer to each other and then that closer means number of turnings of slinky per unit length move away from each other. So when the place or the part of the slinky where the turnings are closer, they are called, that place is called, that point is called compression, and the other point where the turnings of slinky are less in number, that is called rarefaction. So by creating compression and rarefaction in the medium, sound travels from one place to another place, and this is called longitudinal wave. Okay children. So in longitudinal wave, what will be the main thing? Suppose these are the air molecules, they are at rest. When sound is produced in air molecule, when slinky starts vibrating, set into motion, then what happened? The disturbance passes across the length of the slinky. But how? Creating compression and rarefaction in the slinky, and by this way longitudinal wave travels in a medium, and like that only sound also travels. If we consider the case of microphone, that we say loudspeaker. From suppose this loudspeaker sound is being produced, then the sound energy will be added in the air molecule. They will come closer here. Again this sound energy will get added in next molecule, and then these molecules will come back. So over here rarefaction will be created, and the place where the air molecules will be closer to each other, compression will be created. So in mainly what we studied, that in longitudinal wave the propagation of wave disturbance and direction of propagation and vibration of molecules of medium also same. Disturbance created will travel longitudinally, and then molecules will also execute back and forth motion about the mean position, and that is called longitudinal wave. So finally longitudinal wave will travel by creating compression and rarefaction in the medium. Children, in about transverse wave I will explain in next video. It will become longer, and so it takes so much of time to get uploaded. So that's all for today. I'll transverse wave in next video, and I'll show you another activities also for showing transverse wave. Thank you children so much for watching. Again I am telling that this is not the exceptional video I have made for you. So good videos are there in YouTube, but it's my own idea to make videos like this. If you feel it good, understand it, then like and subscribe, and I will be happy for that.